those which do not evaporate. And the process is known as, if a solid directly changes into gaseous state on heating, that process is known as sublimation. Have you heard the term ever? Sublimation. If a solid on heating changes directly into gaseous form, that is sublimation. Okay? Anyhow, so in environment lab we are going to determine total dissolved solid, total suspended solid, then volatile solid and non-volatile solids. You know, in environment lab we have a muffle furnace. There is a heating instrument called muffle furnace, which can maintain a temperature as high as 1000 degrees centigrade. इतना ज़्यादा high temperature generate कर सकता है. What is the boiling point of water? It's 100 degrees centigrade. So this 1000 degrees centigrade, enormous amount of temperature that the instrument can produce. So that will evaporate all the volatile solids, and then we can take the difference in weight and find out how much was the quantity of volatile solid which has evaporated and what is the quantity or weight of non-volatile solid which has still not evaporated. Okay. There are special desiccators or special instruments which can be entered into the muffle furnace. क्योंकि नॉर्मल आपका छोटा सा डिश, पेट्री डिश या कुछ भी, if you keep inside that muffle furnace, that will be damaged because the temperature is enormous, 600, 700 degrees centigrade, 1000 degrees centigrade. So that is why special desiccators are there, which will not be evaporated, which can withstand a temperature as high as 1500 degrees centigrade. ठीक है? The solids can also be classified into organic and inorganic. Organic, which can decompose naturally. Inorganic, which will not decompose naturally, just like silt, sand. Okay, the debris from construction sites, they are inorganic in nature, but carbon-containing things, okay, they are organic in nature. All the food products, खाने पीने की चीजें हैं, the vegetable peels, okay, fruit peels, all the eatable items, they are basically organic in nature. They can decompose, okay, and they also remain in suspended form in wastewater. So it has been estimated that in 1000 kg of sewage, it is around 0.45 kg of total solids, out of which 0.225 kg is in solution form, in dissolved form, 0.112 kg is in suspended form in floating impurities type, and 0.112 kg is settleable, which settles down at the bottom. So just imagine, अगर 1000 kg 1000 kg of sewage is taken, okay, out of that only 0.45 kg, means less than half kg, is the total solids. You know, when we add all the solids, the dissolved solid, the suspended solid, okay, the settleable solid, everything you add up, you will get total solids. So the quantity of total solid is 0.45 kg out of 1000 kg of sewage water, wastewater. ठीक है ना? Further, the solids in sewage comprise of both organic as well as inorganic. I have told organic solids are those which can decompose on its own, which contains carbon as its constituent element. Okay? Inorganic solids, I have told you example, silts, sands, okay, coarse aggregates, gravels, the construction debris, these are all inorganic in nature. They will not decompose on its own. Okay? And they will either settle down or remain in suspended form in water or wastewater. The total amounts of solid present in a given sewage can be determined by evaporating a known volume of sewage sample and weighing the dry residue there. That dissolved solids can be easily estimated by oven drying method. Okay. and the suspended solid can be easily traced out by filter paper. We have Botman filter paper of 12.5 centimeter diameter. With the help of that filter paper, we can trap the floating impurities. And the dissolved solid, we can take the help of oven. By open drying method, the liquid will be evaporated and the dissolved solid will remain at the petri dish or the whatever instrument we have used, whatever desiccator or dish that we have used for evaporation process. Okay, and for distinguishing which one is volatile and which one is not, we have normal furnace which generates a very high temperature. There we can identify which is volatile and which is non-volatile. Second is pH value. pH value we have in our laboratory pH meter, digital pH meter. You know students, the pH is normally defined as minus log of H plus. It's negative logarithm to the base 10 of hydrogen ion concentration. So pH basically is a number. It can range from 0 up to 14. 7th is considered as neutral position. Below 7, okay, lesser the pH value, stronger is the acid, and above 7, higher the pH value, more strong is the alkali or the base. Okay, so we have a pH meter in our lab also. With the help of pH meter, digital pH meter, we find out whether what is the pH value. You know, to distinguish between acid and base, earlier litmus paper test used to be there. In presence of acid, the litmus paper used to turn red, and in presence of a base or alkali, it used to turn blue. Okay, but we were not able to find out the exact pH number. But with the help of digital pH meter, we can easily find out what is the pH value. You know, there is a screen where the number will be displayed. Attached to the pH meter is a probe. Okay, so with the help of that probe, we insert into the water and we can find out what is the value of pH. Very similar to, I think we have done electrical conductivity. Both the groups have done. There was a probe. That probe you used to insert into the liquid whose electrical conductivity has to be measured, right? Similarly, whatever liquid, whatever water, pH we have to know. You will just take the pH meter, we will insert the electrode of the probe inside that liquid or water, and we can find out what is the value of pH digitally. It will be displayed in the instrument. So the pH value is defined as the negative logarithm to the base 10 of hydrogen ion concentration minus log of H plus. Okay. It is used to designate acidity and alkalinity of water. Basically, pH is a number below 7 or above 7. One liquid has a pH suppose 5. Another liquid has a pH say 4. You know what is the pH difference? 1. But this is 10 times more acidic with respect to this. So this is the difference. Means just the pH difference of 1 indicates that the one with lower pH is 10 times more acidic with respect to the one with higher pH. pH in terms of the wastewater sewage, we have discussed. Fresh sewage is alkaline in nature, okay, and the septic sewage is acidic in nature. So the nature of fresh sewage is basically the pH will be more than 7 because fresh sewage is alkaline or basic in nature, and after 3 to 4 hours when the sewage starts decomposing, the pH it becomes acidic in nature, the pH falls below 7. The pH value of fresh and treated sewage is generally more than 7 and less than 7. More than 7 in case of fresh sewage because it's alkaline, and less than 7 in case of septic or stale sewage, because it has started decomposing, it has developed septic condition, it has become acidic. Chloride contains. This also I think both the groups have performed in the laboratory. Chloride determination. Anyone remember what was the name of indicator? Chloride. And what was the titrant? किसी को याद है? In case of chloride, we were using silver nitrate as the titrant. Okay? And potassium chromate. Okay? That was the indicator. What was the initial color that was developing? It was yellow color. In a liquid, you just put few drops of 2 or 3 drops of suppose potassium chromate indicator. It will develop a yellow color. Then you titrate it against silver nitrate, AgNO3. It will develop yellow to brick red color. Okay, and that is the end point. We do the calculation and we find out the value of chloride. You know, a little amount of chloride is already present in drinking water also. ठीक है ना? थोड़ा सा chloride content drinking water में भी रहता है. Why? Because chlorine is a very good or very effective disinfectant. Chlorine is used for treatment of microorganisms. Chlorine is very effectively used as a disinfectant to remove bacteria. You know, bleaching powder, calcium oxychloride, CaOCl2. We use for treatment of water. We use for removal of bacteria and other microorganisms. So a little amount of chloride is already present in water, in drinking water even. Okay, and up to 250 mg per liter. Up to 250 mg per liter of chloride is permissible in drinking water also. So a little bit of chloride is there, but in wastewater, chloride content is much higher with respect to drinking water. Chlorides are derived from the kitchen waste. Why wastewater contains higher amount of chloride? Because wastewater contains extracts, wastewater contains the residues from kitchen waste, from human excreta, from industrial discharges. These are basically contributors of, huge contributors of chloride. That is why in wastewater, the chloride content can be as high as 1000 mg per liter or 1000 ppm like that. ठीक है ना? The normal chloride content of domestic sewage in our day-to-day life, whatever sewage or wastewater is produced, that can contain around 120 mg per liter. If you remember in the drain water that you were testing, I think maybe 35-40 mg per liter like that was the chloride content, right? Because it was the drain water diluted one. Normal day-to-day life में हमारे households में जो waste water बनेगा, the chloride content will be around 120 mg per liter. The higher the chloride content of sewage, that basically indicates the presence of industrial sewage or infiltration of seawater. You know, the seawater, the saline water, समुद्र का जो पानी है, okay, sea and ocean water, they contain much content of chloride. So, if in normal domestic sewage the chloride is very high, that means somehow the sewage has got in contact with industrial wastewater, or if it is a coastal region, then definitely the sewage has been mixed with basically the seawater or the saline water. The chloride content can be made, these are discussed by silver nitrate as a titrant, potassium chromate as an indicator, and the end point is basically yellow to brick red. So this is basically the chloride determination. And the last for today's class, nitrogen content. The nitrogen content can be in any of these forms. The nitrogen content can be in any of these forms. Free ammonia, albuminoid, nitrogen, nitrites, nitrates. That means nitrogen can be present as free ammonia NH3. Okay, nitrogen can be present in the form of albuminoid nitrogen. It can be present in the form of nitrites. NO. What will be nitrite? Okay, nitrates, negative or negative whatever, ठीक है. So basically nitrogen can be present as free ammonia NH3. It can be present as albuminoid nitrogen. It can be present as nitrites. It can be present as nitrates. Now for each of these nitrogenous content there is an indication. Presence of each of these elements indicates something. Okay, that we will discuss in the next class. And next class we will also discuss the most important aspects from where numerical comes in the semester and also in any public exam. You will get that kind of questions. That is BOD, COD. Okay, numericals on BOD, numericals on COD. You will definitely get not only in semestral exams but in any kind of competitive exams. ठीक है ना? So this is very important topic.